In this video, we're going to be talking about the Galilean moons of Jupiter. So Jupiter has a total of 60 plus moons, and the reason why I'm saying 60 plus known moons is because we're not exactly sure how many total moons are orbiting Jupiter. But as of now, we just know that there are 60 plus moons. So the Galilean moons are the four largest of these moons, and they were actually found by Galileo Galilei himself. The reason why the Galilean moons are very important was because back then, humans thought that the Earth was the center of the solar system and the sun rotated around the Earth, whereas in contrast, Earth rotates around the sun. However, when Galileo Galilei saw that when he saw three different Galilean moons around Jupiter, he originally thought to himself, I never seen these kinds of planets before. And then when he saw a fourth one later, he was like, oh wait, these aren't planets, these are moons, and they're orbiting around Jupiter. And he came to the conclusion that that the sun does not rotate around Earth, but rather Earth rotates around the sun. And so these moons are very important, and it led to further space exploration. So now we're going to be looking at these four moons. The first moon that we're going to be talking about is Io. Io is the closest to Jupiter, and it is almost the exact same, is a little bit bigger than the planet Mercury itself. Matter of fact, if Jupiter was not a planet, then we would already be considering these four moons a planet themselves. But anyway, we're going to be moving on with the first one, Io. Since Io is in very close proximity, what happens is that when it is revolving around Jupiter and when the other moons revolve near it, what happens is that it has this kind of tidal flexing. This tidal flexing, as seen over here, Io moves in an elliptical kind of order. When it's closer to Jupiter, one side bulges, when it's farther, it does not. This creates friction within its orbit, and by creating friction, it is known for having its volcanic activity. Hence, it has all this yellowish, orange, reddish, blackish kind of outside or the surface, and that is because of its volcanic activity and its releasement into the releasement of sulfur onto its surface. Matter of fact, it is this sulfur that ends up into the Jupiter's magnetic poles along with Ganymede. However, Ganymede we're going to be talking about later. But anyway, it is Io's sulfur that ends up in the Jupiter's poles over here that create a kind of like aurora, just like we have on Earth. So now we're going to be looking at the inside of Io. Io seems to have a metallic kind of crust, and with this metallic kind of crust, because it is expanding due to the bulging happening over here, it is creating a lot of activity, and this activity results in volcanic activity. Also, it is the only planet other than Earth to have volcanic activity that we know of. So this bulging and contrasting is what is creating this volcanic activity and creating friction within its orbit. Alright, so now we're going to be moving to the next one, which is Europa. Europa is the smallest of the Galilean moons, but it's potentially the most important of them. And the reason why is because when the Hubble telescope and the Galilean telescope, when they were looking at Europa, they saw that Europa seems to have water under its surface. This is also the only other planet that we know to have that we can really say has water under its surface. And the reason why is because when we notice that craters, when they hit a planet's surface, there seems to be crater holes. However, what happens is Europa doesn't have any craters, and it doesn't have any volcanic activity to hide that kind of crater. And because of that, the humans originally in the 1900s have been wondering how no craters or any kinds of comets have been able to hit Europa. And the reason is because of water. Eventually, the water resurfaces all the crater holes, and that's why its surface, or this ice sheet around it, is constantly changing. We can also see these kinds of marks over here, which is basically filled with compound organic materials, something that we're predicting. However, if it's built with compound organic materials, this could lead to signs of life. Even its microbial life, it's still pretty important. But anyway, basically, this is also caused due to the tidal effect happening inside or under the ice sheet of Europa's surface. So basically, the surface is the ice sheet, but inside there seems to be water, the blue stuff over here. And then inside, we have this also metallic core. However, it is not able to generate, like Io, it's not able to generate a magnetic field. Also, because of the tidal effect, the water seems to be staying afloat and is not and only the surface part is freezing. However, the interior parts of the water is not freezing due to the tidal effects happening from not only Jupiter but the other moons orbiting near it. And because of that, this layer is staying melted. So this is going to be pretty exciting discoveries we're going to make with Europa. But next is Ganymede. Ganymede is actually the only Galilean moon to have a magnetic core, and that's because if we look inside of the core, we see that it's made of metallic, liquid metallic elements like iron and nickel, just like the Earth has. And because of that, it generates this magnetic field. Also, just like Europa, it has some kind of water located under its surface. However, it's very deep and it's pretty hard to access. And also, the Ganymede is not as special as Europa because it does not have an ice sheet around it. Instead, it just has a hard molten rock layer. We're not sure if lakes could later develop or rivers could later develop from these underground aquifers, but we're potentially seeing Ganymede just becoming a kind of newer version of Earth. Because back 100 million years ago, what happened was Earth was basically the exact same thing as Ganymede. It was hot. Well, Ganymede's away from the sun, but Earth was hotter. It was literally a barren wasteland with just rock. However, eventually, this underground water was able to leak through, and that's how we were able to get the first precipitation. So we're basically expecting within the next 100,000 years or something that Ganymede will also experience these same things. Also, Ganymede is the largest Galilean moon of all the other moons over here. And lastly, we have Callisto. Callisto is known for basically being the farthest away from Jupiter of the Galilean moons. And because of that, Callisto doesn't exactly interact with the other 3 Galilean moons. Hence, it does not experience the tidal flexing that these moons experience. And so because of that, Callisto doesn't actually have the power to generate a magnetic field. It could, but the problem is it's just way too far, and also it gets much more crater impacts than the other 3. The reason why is because of Jupiter's gravity, most of the craters are going towards it, unless a crater directly hits these other moons. If we look at the surface, we're not exactly sure of what the surface is made of. We still think it's liquid, or it could be solid metallic core. However, it is as of now unknown. And also, Callisto also doesn't have water, unlike the Ganymede in Europa, and it also has the exact same surface as Ganymede. It's just barren rock. And so because of that, Callisto does not exactly have the necessary things to be able to create a thriving environment. So the tidal effect that these 3 Galilean moons, Io, Europa, and Ganymede, are experiencing is similar to the Earth's and Earth-Moon tidal effect. So basically what happens is, Earth and Moon, because of the moon's gravity, the Earth ocean waves are pulling towards the moon. And because of that, it is creating this kind of bulging thing, like over here. And when we're experiencing this bulging thing from the moon's gravity, we're experiencing high tides and low tides. And this kind of tidal flexing keeps the oceans in check. And so this can also be said about these 3 moons over here. They're experiencing tidal flexing, and so this one's able to produce liquid water, this one's able to have some kind of water, and this one's experiencing a lot of volcanic activity. And a fun fact that we could talk about is the orbit ratio of each of the Galilean moons. So, since Io is the closest to Jupiter, it seems to orbit the fastest compared to Callisto, which is the furthest, and it orbits the slowest. For every 1 orbit Io makes, Europa makes 2 orbits. For every 2 orbits Io make, Europa makes 1 orbit, and for every 4 orbits Io makes, Ganymede makes 1 orbit. However, Io, Europa do not have a relationship with the Galilean moon of Callisto. Only Ganymede does. For every 7 orbits Ganymede makes, every 3 orbits Callisto makes, they will line up. And so we can also see this over here, that Ganymede, Io, and Europa can be in the same line, however not on the same side of the line. So Ganymede can be on this side, Io could be on this side, Europa can be on this side. It's one line. However, the problem is that Ganymede cannot be on that side because the math does not show that it can ever be possible. And Callisto, due to it orbiting so slow, it is not able to line up with basically any of the other planetary orbits there. It only lines up with Ganymede. This is all about the Galilean moons which are the biggest moons founded by Galileo Galilei himself, and they were the ones that gave rise to the geocentrism theory, which basically states that Earth orbits around the sun, not the other way around.